Did you know that the EVAP DTCs, or the Evaporative Emissions Diagnostic Trouble Codes, are among the top 10 that we deal with on a regular basis? And the most challenging of these to find and correct are the ones associated with leakage. But stick around, that's the topic we're going to tackle today on the trainer. Before we get started on today's topic, let's first talk a little bit about what the evaporative emission system does and how it works. First, let's start with what it does. We all know that there are emission standards set for the vehicles that we service. We tend to focus, though, on the ones coming out of the tailpipe. This is the carbon monoxide and HC that we worry about. Now, HC, what is that? Hydrocarbons. And what do we also know hydrocarbons as? Unburned fuel. So there are standards for the amount of hydrocarbons that are allowed to pass through the exhaust. We usually measure it in parts per million, don't we, when we're using our 5-gas analyzer. And these are where the standards are set. But where else on the vehicle is there a source of HC? The fuel tank. The fuel tank's full of unburned fuel, isn't it? And it's not the liquid that we're worried so much about, it's the vapors. We have to control the release of fuel vapor to the atmosphere right from the point of the filler neck all the way to the engine where it's finally used in the combustion process. That is the role of the evaporative emission system, to contain and control those fuel vapors. And just like the tailpipe emissions, there are standards set for what is okay and what's not okay. And we reference it by the size hole that would be present that would allow excessive HC to escape. Today we know that as the P0456 small leak detected, the 20,000ths of an inch orifice size that would allow too much HC to escape would be enough to turn on the light and warn the driver there's a problem with his emissions. Now, let's just kind of think about that for a moment. 20,000ths of an inch. Well, the first thing I want you to know is there's nothing in the rule book that says that has to come from one place. You could have multiple leaks that add up to a loss equivalent to a 20,000ths of an inch size hole. Now, how much is that? Well, here's what Bernie Thompson said in an article that he wrote for us not too long ago. He said, think of a dime. A dime weighs a little less than 2.5 grams, not a whole lot. A dime's worth of HC can escape through a 20,000ths of an inch hole over the period of a few miles. And that doesn't sound like a whole lot, does it? But consider that that amount of HC lost, that amount emitted to the atmosphere, is 30 times more than what we allow out of the tailpipe. And now you can see that finding and fixing even those small leaks is very, very important. Let's move on to talking about how the evaporative emission system works. Now I know, yeah, there are as many variations, it seems, as there are stars in the sky. Every OEM has what seems to be their own little take on it. And you're right, there are some nuances from manufacturer to manufacturer that you absolutely want to take a look at before you perform any serious diagnostic work. But there are also some commonalities. There are some essential components that all these systems share, and they all have to do the same thing, contain the vapors. So let's start with exactly where those vapors are contained. Fuel vapors are trapped in a component called the charcoal canister, or EVAP canister. These are typically located underneath the vehicle near the fuel tank. Now, while the charcoal canister may appear to be a simple device, it is rather complex, and there are some things that can come into play when you're diagnosing a problem with the system. First, the canister contains kernels of activated charcoal. It's this activated charcoal that actually adsorbs, not absorbs, adsorbs the fuel vapors and holds them in place. Now, there is a limit to what a charcoal canister can hold. So if there's a problem, for example, of raw fuel getting into that canister can become damaged very, very quickly. Another factor that comes into play is the vehicle use. A vehicle that suffers a lot of severe off-road kind of duty, a lot of dirt roads, bumping and bouncing, can cause those kernels to become pulverized, which again reduces their ability to contain the vapors. It can also cause the partitioning walls inside the charcoal canister to fracture, which would allow some of those kernels to escape to parts of the system where we really don't want them. And another factor that comes into play is when the fresh air vent becomes damaged and allows dirt and other debris to enter the canister and further reduce the amount of flow possible through the canister. So there's a lot of factors you want to consider when you're inspecting that component. Now, as I mentioned, the charcoal canister can only contain so much fuel vapor. We have to get rid of the vapor from the canister. We can't release it to the atmosphere, so what are we going to do with it? Well, we're going to draw it into the engine and allow it to be burned with the rest of the unburned fuel that we're sending to it through the fuel rail. That's controlled by a component called the Purge Valve. Now, it may go under different names depending on manufacturer, but essentially the role of the Purge Valve is the same. It's controlled by the ECM, typically through a pulse width, and the duty cycle will be dependent on what the ECM thinks or how much fuel vapor it thinks it needs to withdraw from that canister and get into the engine. We can't do too much at one time, can we? Because then we'll start affecting the fuel mixture and the fuel trims, and that's going to skew those numbers. We can't do too little or we won't get the canister clean. So the ECM controls that valve. Engine vacuum is then applied to the canister. That draws the vapors into the engine to be burned. Only one problem with that though. If we open the purge valve and start applying vacuum to the canister, it's not going to take very long to create a balance in the vacuum in the system, and then all flow is going to come to a stop. In fact, we could cause some damage to the lines if the vacuum applied is greater than that line can handle. So we have to have a way to keep that balance. We want flow, air flow through the canister. So what we're going to do is we're going to add something to the back door. It's called the vent valve, and this allows atmospheric air into the canister when the purge valve is open to help draw those vapors into the engine without causing any issues in the system. Those are the components that make up the foundation of the evaporative emissions system. Now let's talk a little bit about the onboard testing of that system, again with a focus on leaks. Essentially, all we really need is some way to either change the pressure and vacuum in the system and monitor that pressure and vacuum for loss. Fairly simple, right? Most systems made by the OEMs today use vacuum as a preferred testing method, but there are a few that use pressure. Those that stand out in mind are the Chrysler LDP or leak detection pump and BMW's DMTL system. Most of the others use vacuum as their preferred way of checking the system. So what do we need to do that? Well, we need some way of measuring the sensor or the pressure in the tank or vacuum in the tank, and that's going to be at the fuel tank pressure sensor. Now, how are we going to create or monitor that? How are we going to run the system through the steps? The first thing we're going to do is we're going to open up the purge and the vent, and then we're going to make sure that we have the ability to draw a vacuum through the system. What we should see in the pressure sensor is just a real small vacuum develop when both valves are opened. Once we know that we can actually pull a vacuum on the system, we're going to close the vent solenoid and we're going to leave the purge solenoid open. Now we're going to draw the system into a vacuum to a specified point, again, as monitored by the fuel tank pressure sensor. Once we've reached that point, we're going to close the purge solenoid, and now we're going to watch the signal from that pressure sensor. We're going to be looking for vacuum decay. Does it hold? Depending on the rate of decay is a measure of how big that hole size is, and that's what's going to end up turning on the light. Okay, here's a diagnostic tip for you. When you're faced with one of those especially small leak challenges that you just can't find the leak, there may not be one for you to find. One of the factors that comes into play is how much fuel is in the fuel tank. And how does the ECM know? It goes by the fuel level sensor. If that's providing an inaccurate reading, that could provide inaccurate data for the ECM to use in performing that leak test. And that could result in a ghost code that really doesn't exist. So consider that when you're chased with that problem. Is that fuel level sensor telling the truth, or isn't it? And while you may run into those really tough ones from time to time, the majority are not going to cause you that much difficulty if you remember these 3 keys to success. Make sure, like we told you on every other diagnostic, that you understand the system that you're working on and how it operates. Second thing, do your homework and understand what the diagnostic trouble code is, what's its enabling criteria, how does the ECM know when to turn the light on, how does it test for that particular malfunction. And then last, but certainly not least, know your diagnostic equipment. Vitally important if you're going to have success finding those especially small leaks. I'd like to move on now to talk a little bit about the tools and techniques that you can use to help you find those small leaks. But before I do, there's a couple of things that I want to stress. We just went over the general process used to test these systems for leaks, and that was relying on the fuel tank pressure sensor, wasn't it? First of all, keep in mind that pressure and vacuum changes in this system are very, very small. They're measured in single digits. And for example, vacuum in the system, not measured in inches of mercury like we're used to seeing on your vacuum gauge. It's measured in inches of water. So it's very, very low levels of vacuum and or pressure that we're trying to detect here. And because of that, because that small leak can cause such minor fluctuations, a lot of the OEMs have specialized processes that they use specifically for testing for those small leaks. So make sure, like we said earlier on, the very first thing you have to do is be sure that you're clear on exactly how the system you're working on tests for leaks, so that you know what you need to be looking for, and when some areas may be affected that really aren't a leak at all. Maybe it's that particular component that's improperly located or has a problem internally or something along those lines. Another thing, of course, we want to check is technical service bulletins. A lot of problems with the vehicle setting the small leak codes are a result of an error in the programming, and there's a flash out for that to correct that problem, turn the light off. All right, so what we're going to focus on tools and equipment and techniques for finding the leaks, general process, and one of the first things we're going to talk about is your scan tool. Now, there are a lot of scan tools on the marketplace today. Many of us use aftermarket tools that have what we call enhanced data for the model lines that we service most commonly. And you've heard me say a number of times that I can successfully diagnose most OBD2 problems, ECM powertrain problems, using a global OBD2 scan tool and not really need the enhanced data. But here for EVAP systems, I'm going to encourage you to make sure that you have the enhanced data available for that model line. Why is that? Two reasons. First, a lot of the data that you're going to want to look at to help either find the leak or verify that you fixed that leak is only going to be available to you in that enhanced data list. The second thing that you're going to want to have the enhanced data for is for the system tests and the bidirectional controls that you may need, either as outlined by your system information and troubleshooting information, again, to either find or verify that you properly fixed that leak. Now, one of the things that you're going to have to do in order to test the system for leaks is seal the system. Now remember the solenoids or the valves that we talked about early on, the purge and the vent? Well, typically the purge solenoid is closed and the vent solenoid is open. Well, I can't test the system by applying any kind of pressure to it, can I? Unless I have the system sealed. So I may be able to use the bidirectional controls in enhanced mode to close that vent solenoid without having to do anything fancy, and then seal the system and start with my leak test. But here's a tip for you. If you don't find it in your enhanced data, you still can check global OBD2, specifically mode 8. That's control of onboard systems, and for the most part, if it's available, it will allow you to do what I just said. Close the vent solenoid so you can perform your EVAP leak test. Now, if neither option is available, you're going to have to use another method in order to close that solenoid and proceed with your test. Let's talk about leak testers next. The next piece of equipment that I want to talk about is your EVAP diagnostic machine, commonly referred to as your smoke machine. Now, there are several on the market. I'm not trying to promote one or the other. I just happen to be using the Smoke Wizard today as the example in this session. But it's got some nice features on it that you should look for. First, I have a flow gauge that can help me determine whether a leak is present or not. And I also have a combination pressure vacuum gauge, again in inches of water, so that I can help look for the decay rate, just like the ECM does, again looking for those very small leaks. There's a flow control on the machine. The first question we want to answer is, what do I connect to the inlet side of the machine? Many of you are using your shop air to do that, and I'm going to tell you, I don't personally prefer that. A couple of reasons why. Number one, I don't know how clean my shop air is, so I don't want to do anything to harm my equipment in the process. I don't want to be dumping oil or water or metal particles or whatever else might be in that shop line, to get into my machine. So that's one. Number two, Many manufacturers caution you against using compressed air because you're mixing air with fuel vapors. You can create a more explosive atmosphere than was there to begin with. It's a safety hazard, a potential safety hazard, so why bother with that? When another answer is very, very easy to do. Use an inert gas like nitrogen, or my preference is CO2. In fact, this machine actually comes with the adapter so that you can take a 20-ounce bottle of liquid CO2, the kind that you can buy at any paintball supply store, and connect this to the machine and use that as your gas source. And there's a couple of good reasons for that too. First, we avoid that flammability issue by using CO2. The second one is the CO2 molecules are much smaller than the molecules that you'll find in shop air, the mix. And because of that, the CO2 will escape from a small hole when maybe air won't, and it makes the leak that much more difficult to verify and, of course, spot when you start putting the smoke to it. The next thing I'm going to tell you is don't go right off the gun and start pumping smoke into your system. You know, make sure that you verify the leak exists first, or you're just kind of spinning your wheels and wasting your time. Also keep in mind that the molecules in smoke, a couple of drawbacks that may cause you a challenge in finding that very small leak or that leak source. Because these are petroleum-based products, typically, the canister is supposed to absorb hydrocarbons, right? Adsorb hydrocarbons. So some of the smoke may be trapped in the canister and not get to the leak source. Other things that you might run into with the smoke, again, is the size of the molecules in the product that makes up the smoke. It may be too big to get out of that hole. Like I said at the very beginning, the spec is 20 thousandths of an inch, but that doesn't mean that it's your small leak code is set by a 20 thousandths or bigger hole. There could be multiple holes that are causing that leak rate, and you may not find those smaller combinations using shop air or using smoke. So there's a few things to consider there. But for the most part, you'll be able to find the majority of them using a good quality EVAP tester like this one. Now, let's still talk a bit about the technique. Here's what I like to do with my machine. Once I go ahead and get it hooked up to the system, I'm going to turn it on, and you're going to notice that it takes a while for the ball to start coming down. And that's because I got to fill all the airspace that's in the system. The lower the fuel level in the tank, the longer it's going to take to fill that space. Again, another tip from Bernie Thompson's article that he wrote for our magazine. If you want to get an idea of how long it takes to fill that space, take a clean 5-gallon container and then use your equipment to fill that container. And you're going to have to do that several times while you time it. And when you see the ball drop all the way to the bottom, indicating that the system's been filled and there's no leaks, count that number of seconds and use that as a guide. So for example, if I have a 20-gallon tank specified for the vehicle I'm looking at, and it's half full according to the gauge, that's 10 gallons, that's divided by 5, that's 2. So whatever time I counted, let's just say 10 seconds times 2, 20 seconds is what it should take to fill that airspace, give or take a few. That can give me an idea if there's a restriction in the system, maybe the fuel level sensor is inaccurate, anything like that that was just going to raise a flag that can help me find that small leak a little easier. So that's not a bad baseline measurement to use. Now, once it has gone all the way to the bottom, first, if it bounces around like you see here, well, certainly that indicates that I have a leak. It's large enough where I'm not going to get the pressure all the way to the bottom. But if I have a situation like this one, where I do have it now all the way at the bottom, okay, now I can turn off the system and I can monitor the pressure gauge and watch for decay. If I start to see that being lost almost immediately, then I have a leak. It might be small, but I do indeed have a leak. And now I can proceed with more precise troubleshooting. Okay, so let's just say that we've got our smoke machine hooked up and we noticed that it got down to the bottom, the ball flow valve got down to the bottom, flow stopped in an expected amount of time, so we don't expect there's any problems with the fuel level sensors, there are no TSBs, but we're monitoring the decay of the pressure of that pressure that we put in the system, and we see that it is losing pressure. We know we have a leak and we have a small one. Those are among the most challenging, of course, to find. As I stated earlier, already a couple of times, the standard is 20 thousandths of an inch, but that doesn't mean that it's always going to be one 20 thousandths of an inch or bigger hole that you're trying to find. It could be multiple smaller holes that are giving the same leak rate. So what I would encourage you to do is, once you've determined that yes, there is a leak, we can see the decay, I've proven that, break the system up into parts. For example, I would break it up into the purge side and the vent side with the canister in the middle. I would take the lines loose at the canister and I would close off the purge side and apply that pressure again and monitor to see if the same amount of decay returned. If it did, well, I know that that's the side of the system I need to focus on with the smoke test to find out where exactly it's leaking from. If it didn't, well, I'm okay with that. I can set that off to the side and I can move on to the other half of the system. So break it up into components and check the components individually. Keep in mind that when you're checking the filler side of the fuel tank, that many vehicles have that rollover valve in place so that when you apply pressure to the tank, you're going to close that rollover valve, and that's going to keep your test pressure from going any further. So you want to make sure that you are testing the fuel filler and the cap. You may actually have to go in from the fuel cap side. And while we're talking about the fuel caps, resist the urge to immediately check to see if the cap is tight. Sure, inspect it. If it's missing completely, well, then you have an idea of where that leak code came from. But that small leak could be caused by a bad seal in the cap that you're going to fix without knowing it when you go in there and just give it a couple of clicks. So resist that temptation, verify what the problem is first, and then if you see that small leak, you want to give it a couple of clicks to see if it goes away, that's okay. That I wouldn't have a problem with, and you would be not wasting your time that way. A few other things when you're checking for leaks I want to make sure you're aware of. As I commented on, in some cases, the air that you're using is not going, if you're using shop air, that's not going to get past those small holes because of the size of the molecules involved. If you're using CO2, then the odds are, yes, it'll get past that small hole and you'll be able to get the leak detected that way. Again, though, the smoke may not, again, because of that molecule size. So wouldn't it be neat if there was something we could use to sniff it out, just like we do on an air conditioning system? Well, there is. It's actually part of the system that Bernie Thompson developed over at Automotive Test Solutions. It's called the Bullseye Leak Detection System. Hey, this is not a promo, guys, but if something works, I'm going to tell you about it. This is a CO2 sniffer, and it can come into play to help you find those leak sites when other methods have been leaving you hanging. Now, I'm not saying that that's going to happen every single time. There are many, many, many leaks that you'll fix just fine using the procedures that we've talked about so far. But you're looking for that pesky small leak or those multiple leak sites that you can't find otherwise, this tool will help you find it. And because it detects CO2, there are a lot of other uses that you can apply this equipment to too. Bernie also developed a foam so that when the foam is sprayed on that suspected leak site, it'll actually change color in the presence of CO2, just confirming you're on the right track. So that's a tool that you might want to consider to help you if you're really trying to find those really, really small leaks that are driving you crazy. Here's a few other tips for you when we're talking about trying to find those pesky small leaks. One, get yourself one of those little laser pointers, you know, the kind that kids like to play with cats with. You can use that too to help spot leak in those hard to reach areas where you can't physically see it. But when you pass the laser through it, you know, kind of like the spy guys do when they're looking for where the alarm laser beams are and they spray that smoke over it. Well, same thing, but in reverse. So that can help you spot where the smoke is. Another common problem are solenoids or valves, either the purge or the vent valve, that stick when they're in service. So sometimes they're stuck or they're leaking just a small amount. You can find this a couple of ways. You can monitor that pressure decay like we talked about earlier as you operate those valves repeatedly. And if you're going to operate the valve, use your multimeter in amps mode. And what I mean by that is if it's a ground-controlled solenoid, say a vent solenoid, and you want to check it for a problem, then you can ground the side of the solenoid through your ammeter to a chassis ground, and you can just repeatedly on and off, on and off. Don't leave it connected for long, okay, or you're going to overheat and damage the valve, but you can click it on and off, on and off, on and off several times, a few dozen times, and then watch the current flow. Okay, if there's a problem electrically, won't you see that in the amount of current flow? You know, if it starts to heat up and goes open, well, you'll see a change in current flow. So that's one way you can check it. You can also, again, monitor that decay rate, and if you keep a pressure applied to it, if it builds and goes away, builds, goes away, builds and goes away, and then doesn't build again because now it's not closed, that could be another giveaway. Sometimes simply just blowing on it, making sure that it goes one way and doesn't go the other is a test. But keep in mind that those intermittents will affect you. And like I said before, first and foremost, check your system operation, make sure you're clear on that. Check the TSBs. You can also check your other resources. But if you do find that silver bullet by doing a research through any of the portals that are available, make sure that you verify before you just jump to that as the solution. Remember our motto, test, don't guess. That's all the time I got for this edition of The Trainer. I hope you found it helpful. I'll see you next month.